Transformations of absolute value functions. We're going to look at how to make the function move, the absolute value function, move around the chart and look at some basic transformations. So let's look at the parent function. The parent function has a vertex at the origin. It on the right hand side is going up, and on the left hand side is going up. The lowest point we go to is 0, so the absolute minimum is 0, and the maximum is going to keep on going up. Our domain is all reals, but our range is from 0 to positive infinity. Our key point that we are going to be starting with on each of these is that vertex, which is at 0, 0 here. And the other key feature that we are going to focus in on a lot is the fact that we will go up 1 over 1 to get to the next point, going to the right, and then up 1, left 1 to get to the left. So let's take the first one. What happens if I have a plus something at the end? If you have your vertex has now just been shifted up, you still have that slope of up 1 over 1 each way. Then all you've done to your function is f of x is equal to the absolute value of x plus whatever your shift up is. In this case, we moved our vertex from the parent function. It is now 7 units up from where the parent function would have been. So it's f of x is equal to the absolute value of x plus 7. A shift down, all it is, we're adding a negative d. And so we are going to do f of x. In this case, we shifted down 2. And so absolute value of x minus 2. Now let's look at what makes it move right and left. If we want to move to the right 3 units, we're going to shift to the right 3 by putting in the number inside the absolute value. So to go from the vertex, which was at 0, 0, to the vertex that's at 3, 0. And again, right now, I am the slope that's leaving, we're going up 1 over 1 each time. And so f of x is equal to the absolute value of x minus 3. When we're inside the absolute value, to go to the right, we're doing minus 3. And so to shift to the left, it's going to be the opposite direction. And so our vertex was at 0, 0 with the parent, but now is at negative 6, 0. So we shifted left 6 units. So f of x is equal to the absolute value of x minus a negative 6. But instead of writing minus a negative, we will usually write just the plus, as minus and negative is plus. Now let's try if we have both shifts. So we both have a shift left and or shift left and right, or a shift up and down as well. And so we're just putting it all together. So from the parent function, which is at 0, 0, we've had to go left 2 and down 3 to get to the new vertex. Our slope's still staying the same. We're going up 1 over 1 to get from each point. So each of those is going up 1 over 1. And we have the symmetry on both sides of that vertex. So when we put it all together, we end up with, since we went left 2, the left is inside, the down 3 is on the outside. So the absolute value of x minus a negative 2 outside of the absolute value we have a plus a negative 3. And so to simplify our signs, f of x is equal to the absolute value of x plus 2 minus 3. Another transformation that we will see is when that graph has been stretched vertically by, looks like someone pulled up on it and made the line steeper, and what affects either the lines becoming steeper or less steep is the number in front of your absolute value, and we're calling that A. This time, instead of going up 1 over 1, I went up 3 over 1. And so f of x is equal to 3 times the absolute value of x. So this time, I still kept that stretch of 3 that we had last time, but this time it's pouring out. And when it's negative, it's upside down. You're spilling all your contents out of the absolute value. So we reflected over the x. And so f of x is equal to a negative 3 times the absolute value of x. So if we want to reflect it over the x-axis, we have to put a negative on the outside of the absolute value. Because if it's on the inside, it's not going to matter. So I told you we can either stretch it, make it taller, or compress it. And the compression is in the same spot that the stretch is. It's just another way of saying a stretch. It's just a push in. So we're compressing it vertically. And so f of x is equal to, now we still have a reflection over our x-axis, so it's a negative 1/2 times the absolute value of x. So let's put it all together. We're going to have a compression of 2/3, because if we look here, instead of going up 1 over 1, we went up 1 over 3. So that's where that 2/3 comes in. It's just kind of like a similar idea to slope. So I have f of x is equal to 2/3 times my absolute value. Now, the original vertex of the parent function absolute value of x was at 0, 0. The new vertex is at -4, +5. So I have x minus a -4 plus 5. And so when I work through what's inside and find my signs, I have x plus 4 inside the absolute value plus 5. Now, the one spot we haven't tried to multiply yet by is inside the absolute value. And this time we see a stretch of 2. Another way we could have this stretch is on the inside the absolute value. And so we could see f of x is equal to the absolute value of 2x. But because the absolute value is there, it could also be the -2x inside the absolute value. We can't tell if it's positive or negative inside. It is typically written as the positive just because we tend to think in the positives more. So the answer a circle is the most common way you'll see it written on that. But that stretch can also come into play from inside the absolute value.